Hey, welcome back. This is another Shoptalk episode. It's June 2019 and I have a very large collection of smaller video clips that I want to share with you. So let's get right to it. So up until recently I had this Far East import sandblasting box or blast cabinet, and it kind of worked. It gave me good results that I wanted. But it's not made very well. Dust gets out of every corner of this thing. And the gun is the main problem in this thing. It's one of those, air goes in here and the blasting media gets pulled by Venturi principle through this hose. And this chamber here gets mixed with the air and blasted out through this ceramic nozzle here. Problem is you lose a lot of power, a lot of your power that you would prefer to have on your workpiece by the blasting media. You lose a lot by having to suck all the blasting media through this hose. And yeah, they are relatively inefficient, not very well made. A little bit painful. I ran this cabinet with a mixture of glass beads and aluminum oxide 50 micron, which gives a nice finish. So this worked, but I wasn't happy with it. It needed a ton of air, which my small compressor out here in the garden shed could not supply very well. So I went online and looked what people buy. And everybody told me to get this blasting cabinet from these guys, Logiblast.at, which is an Austrian company, small company, which builds small, affordable, kind of affordable, this is still rather expensive, blasting cabinets and blasting standalone units. I will come to this in a second. This whole setup is about 400 euros, so it's not really cheap. It's about 10 times the price of the small import blast cabinet. The cabinet itself is not made out of sheet metal. It's screwed together out of machined debond plates, which is 4mm PVC core in the center and aluminium sheet on both sides sandwiched together. Relatively sturdy, but insanely lightweight. The top opens up, but you can also lift it off completely if you want to put something larger in it. Has weather stripping running all the way around. The two gloves to manipulate your work on the inside, and we have this on the right side here. This is the actual blasting unit. This just hooks to the side of the blasting cabinet and the hose goes inside the box. What this is it's a pressure vessel which contains the blasting media. It contains about 1 liter of blasting media. Turn off the air supply here with this large lever. Then you can open it up here. You fill it up with your blasting media. Just put a funnel in and you take your blasting media, glass beads or aluminum oxide or walnut shells or whatever, fill it in, put the cap back on and you repressurize the tank. That's it. That's the trick with this gun. This sandblaster has not to use your blasting pressure to suck the media through a hose into the airstream. It pressurizes the container with the media and blows it out through the nozzle. So it's all once it's a fully contained system. That's also the one drawback on this system. You cannot run this continuously. When this container with 1 liter of blasting media is empty, you have to stop, open it up, fill it up, and you're going again. You can take this off this hooks to the side here. You can take this off, and you can even use it on site if you want to derust your whatever, something that's too large for this cabinet here. You can take this outside and you use it on site to do your sandblasting. Of course, you need the proper safety equipment then. Face shield at least, dust protection, protective gloves, whatever. I do not plan to do this. That's the compressor I'm running. This is a 50-liter tank, and I think this is something like 205 liters per minute of air delivery. Also here you can see, along with the blasting cabinet, I ordered the foot switch. I'm used to a foot switch on a blasting cabinet from work. It's very nice to be able to use both hands to manipulate your work and just use a foot to control the blasting media itself. Only drawback, if you have large feet, this is almost a little bit too small. Okay, this is a look. I took the glass the plexiglass cover off. This is a look inside the chamber. It's very bright. The white debond gives a very nice reflective surface. Chamber has LED lighting facing away from the user down here. So you do usually not have a shadow on your work. Gloves are decent quality. They do not stink at all compared to the ones that came with the import box. And here is the blasting media. This is a mix out of, I think it's 120 micron glass beads and 50 micron aluminum oxide. This cabinet does not have a real blasting gun. It comes with a hose and it has nozzle on the end, and you just hold it like this, like a pencil. It's a very simple construction. It's just a push fit pneumatic connector, 6mm on this side and I think 8mm on this side, and it has a carbide nozzle in it. The carbide nozzle is suitable for glass beads. The manufacturer recommends a cubic boron nitride nozzle for aluminum oxide, but right now I have only the carbide nozzle here, so I will just wear this out. Then I will get a boron nitride nozzle. Until then this will do fine. 1.2mm nozzle, larger sizes are available too. So that's the Logiblast smart cap. Down here, almost forgot to show this. Down here is a cover. You undo this, then you brush all your blasting media in this port here, and you have this drawer outside here, which now contains your blasting media, and that just goes back in the container up here. Refilling the blasting media tank doesn't take very long, and it's really simple, so that's okay for me. I'm running this currently at 2 bar, which is something like 35 psi, and that's very suitable for the work I do with it. I might have to add that I'm not affiliated in any way with this company. I just bought this for myself, paid full price, no affiliation, just a seriously happy customer here. Here are the examples I just showed in the cabinet. Let's start here. This is a piece of high-speed steel that has been wire cut into the shape of a small sine bar. The surface finish starts something like this, the EDM recast skin. It's very rough and it looks not very nicely. And after blasting it with the aluminum oxide, the glass bead mix, it's really nice finish. I left on each of the examples I left a little bit of the original surface next to a blast surface. A little piece of aluminium. This is belt sander finish. 120 grit belt sander. Cleans it up very nicely. And this is the original tooling plate finish that you get on this precision aluminium tooling plate. When you blast this, you get a very even finish. Piece of carbon steel, cold rolled or cold drawn. Down here is the cold drawn surface, and up here blast finish. And this is a phosphorus bronze bushing. As you can see, this gets also very nice finish. You have to be a bit careful in softer materials if you run it at very high pressure. You can be able to embed abrasive into the materials you're blasting, especially with aluminium or possibly with bronze. So that's the results I get with this blasting cabinet. I'm very happy with that. And you will probably see a lot of blast finished parts in future. Also, this works very nicely to deburr plastic parts. If you load ground up walnut shells into it, it's great for deburring plastic and giving a very even finish. Okay, this is a microscope view of high-speed steel sign bar that I blasted. On the right side, this is blasted obviously, and this one over here still has the original wire EDM surface. I think this is a better example. This is the brass bushing that I blasted, or bronze. Here you can still see the lines from turning the bushing. These are spaced by the feet per revolution of the tool that was done when this part was made on a lathe. And when we go up here where I blasted the part, these lines are gone. A very homogeneous surface here, a little bit rougher than the turned finish. Turned finish is almost very reflective, and this is a little bit scuffed up. That's also because I'm running the aluminum oxide in the media mix, but it's really a nice finish, and you cannot see the individual lines of turning this diameter anymore, but I can scratch it. Hey, yeah, that's some bronze under the microscope. And lastly, the aluminium belt sander finish down here, 240 grit. Up here, blasted. This does not get rid of the grinding marks of the belt sander. These are too large. You would have to blast this for considerable time, preferably crosswise to the lay of the grind. And relatively flat, at a flat angle, so you get more. I found that you get more of an abrasive effect if you go flatter against the surface you're blasting. I did a minor modification to my milling machine. If you remember, I did a video on the depth stop, the precision depth stop. I had always had a small dial indicator in here that showed me the last 10 millimeters of travel of my depth stop. That means when I got close, I could see on the depth stop the remaining distance. That worked perfectly fine. The precision of the depth stop in combination with the dial indicator was really good, but it was relatively clunky and slow if you had to do work to a lot of different depth setups or depth settings. I have a linear scale, a glass scale on the head movement of this milling machine. That's fine, but for when using very tiny tooling and doing very small adjustments, I prefer to use the Quill. It's just more sensitive. So I decided to ditch the dial indicator. I bought another import linear scale, 5 micron reading, 120 millimeter travel. And I mounted a bracket here to the head of the spindle of the mill. It's aligned that way and shimmed in this way, so it's traveling true to the Quill. And I machined a small bracket that rides on top of the depth stop rod and mounts to the read head of the linear scale. That way I get full additional access of with a readout that I can see here on my DRO, and this really works nice. It's very easy to go to a certain dimension, and I used this now for a little bit over a week, and I could hit myself for not doing this earlier. There are also these Mitutoyo readout heads that are the same function principle as a digital caliper that you mount to your Quill as a readout, but those do not feed back into the DRO, which is nice because the DRO has some functions that you can use with a full C-axis, like you can cut radii on the side of a part with ball end mill, and the DRO will show you the positions you have to adjust your C-axis and your X or Y, depending on which direction you use it. Of course, this is a 3-axis readout, and I have 4 linear scales on this machine: X, Y, C, and the Quill. So right now I'm just unplugging the C-axis linear scale and plug in the Quill scale, and vice versa, whatever I need. But right now, most of the time, the Quill scale is plugged in. I will probably buy the 4-axis version of this head. There are versions that can do 3-axis, 3+1. That means that you have X, Y, and you can have 2 inputs on one readout position. So both scales add up or count together. But I don't like that. I want my 2 scales individual. Same for a lathe. I never liked... I worked on machines where the compound scale and the carriage scale added up in one readout position, and I absolutely dislike that. Not the way I like to work. I got also asked why I don't use the touch DRO. While the functionality of the touch DRO is really awesome, it can basically do anything that a high-end DRO like the Heidenhain that Robin has, a programmable DRO. The touch DRO can do all that, but for me it's a no-go because it's a touch display. I don't like touch displays in the shop. I absolutely dislike them. I want tactile buttons, even if it's just these snap domes, which are also okay, but I can hit those blindly. I can go here, hit X0 for example, if I want to, without having to look very precisely, just by feeling it. It's just preference. And also the LED displays in here, the 7-segment LED displays, these are very easy to read. My preference, absolutely. I don't like touch displays in the shop. When I look at my phone, how grungy this is when I have it out in the shop. Can't imagine having a touch display on a machine. Also, that's one of my gripes with one of the new Datron machines with the touch DRO. In my mind, that's not exactly what you want in a machine shop. But that's just my opinion there. I still have my hard depth stop that I can use. I did not lose that functionality. I still have the full depth stop rod here to be used, which is nice for repeatable work. And here's the bracket that goes from the depth stop rod. It's bolted on axially with a single M6 screw. Goes out, welded on cross member here, and bolted to the reed head. Not a very substantial bracket because there is no force on this whole contraption except for the pull of the cable. Running the cable in a nice large loop there. So if I go full travel here, I do not put any strain on the reed head and all is good. I needed to take apart a Albrecht 0 to 6 millimeter keyless chuck. We begin by removing this ring on the back. Then we make an oil filter or a lens wrench out of aluminum, which is just bore the hole and then bands out to shape. And this pinches the diameter you grip with it. Holding the chuck in the lathe, then unscrewing the front cone counterclockwise. That's the way these chucks come apart. Here you can see the 3 jaws that move out and clamp your drill bit. You can just pull them out to the side with a pair of parallel gripping pliers. The inner part just can get just knocked out to the front, and then you can pull it apart. And inside there you can see a row of ball bearings. These are important, so don't lose them. That's also the reason why I take it apart over a plastic tray. A lot of sticky grease in there, and that's also the reason why I'm taking it apart. It moves very sticky, so I decided to take it apart and give it a good clean and a good lubrication with fresh grease, and then I put it back together. Okay, you're probably already sick of seeing these plastic parts. I showed them numerous times before, and once again I changed my process to make these. In the past, after I machined them on the lathe, I put the 3-jaw chuck or the 6-jaw chuck here on the CNC router, and then I milled this internal contour. Problem is, usually when I do this, I need the same chuck on the lathe for some or the other reason. And also it's quite annoying to put the chuck on here. You have to put the chuck down, you have to find strap clamps, and so on and so on. It's really annoying. So I decided to make some expanding arbors to hold these parts without any additional work holding tools. These are just turned out of Delrin. Let's get the screw here out. This fairly long screw. The screw is so long because I'm threading into plastic, and in plastic you want fairly long thread engagement, at least 2 times thread diameter. This is an M10 bolt, so it needs a fair bit of length. It's a flathead screw with a conical head here, and that spreads apart these 4 segments, which is, it's turned to the diameter, to the internal diameter of this part. Then I slid it with an end mill, just a very wide slit with a 6mm end mill. Then I went back to the lathe and I used a parting tool to undercut it here, to a depth of almost 2/3 of the diameter, so these segments can flex out like this. If you push down here on the middle, these segments will expand out and grab the part very secure. And the trick with these arbors is to get a repeatable result. Not only to have an expanding section here, but also to have a non-expanding section down here. This diameter has the same diameter as the expanding section up here, but this down here does not change when you expand the arbor. So this diameter down here, this defines the location of the part, and this expanding section up here, this is what clamps the part. And it really works marvelous. You put the part on, take a hex key. Oh, by the way, if you wonder about the flathead screw with the cap head screw in it, I didn't have a flathead screw with an internal hex, and I'm not the biggest fan of slot head screws for anything, especially for fixture screws that need to be moved on a regular basis. So I drilled and tapped the M6 and Loctited it in a M6 cap head screw. Part goes on like this. Tighten down the expansion screw and it's locked. And that's a very fast way for work holding. Have a second expanding arbor over here. Same design. Non-expanding section down here. These 4 segments here again are slit and undercut with a parting blade to relatively small diameter, so these leaves can move out once the part is put over. The weird shape of these parts and the additional holes are caused by the fact that this is made out of a different fixture that I don't need anymore. And this one is made so I can hold these covers for drilling. The 10mm hole in the center is already there from turning them in the lathe, and it's quite convenient because that gives me a way to reach in to tighten and loosen the arbor. That's also a very good way to secure these parts. And the way this arbor is designed, it also, when the leaves expand out, they also put a little bit of downward pressure on the part, so it pulls it down onto the flat surface here. And both of these arbors are just screwed with 2 screws and 2 T-nuts to the table of the mill. Centering them is very fast. Just pick up 4 points and find the center, as usually, or use a dial test indicator and sweep it in. But the precision on these parts is not critical, so I usually just pick up 4 points and find the center. So yeah, that's 2 arbors. Sometimes even on low numbers it pays very much to build custom work holding. In this case I will keep the screws and the T-nuts together with these arbors, so each time I run this job I just have to slit them on the table, screw it down, center the part, and I'm good to go. And I usually do about 10 or 20 of these parts in a row, so it makes sense to build something useful. This is me, first time using the large Kuroda boring head in the RF45 mill. I have 2 cast iron clamping blocks to hold NSK high-speed spindles on a machine tool, and they need to be bored to a relatively precise diameter. I'm running at 580 RPM. Feed of 0.035mm, that's 35 microns per rev, and a depth of cut of 1mm. Let me dial in the depth of cut. That's quite nice on this boring head. Should that didn't tear down, just open the lock here, then you adjust it. One full revolution is 1 millimeter in diameter. 1 millimeter. And there's 2. And this has a graduation in 10 microns per division. Using the Quill feed. The tool is something that Robin Wren said he showed on Instagram, which is quite a good solution. He uses linear shafting, case-hardened linear shafting that's ground, grinds a flat on it so it orients with the set screw here, and he silver brazes whatever cutting implement he needs on the end. In this case, I just brazed a piece of 6mm round carbide on it, and I ground it on a D-bit grinder sharp. And then I used a very fine diamond wheel to give it a good finish. Okay, let's go. There we go. Now we orient the boring head in a way so we can clear the boring bar, put it at 90 degrees and move the table over a little bit so we do not scratch the wall of the bore when we retract the tool. Then we go back to 0. That's easy to be done with DRO or dial indicator that reads against the table. But we have to move the table sideways anyway because we want to check the diameter. Should be 28 point something something something. The finish is really nice. The relatively fine feed per rev and this very stiff large diameter boring bar gives a good finish, no vibration, no drama. Keep in mind, no matter what steel you use for the boring bar, as long as it's steel, no matter if it's hardened or unhardened, the module of elasticity is always the same, so the boring bar is always deflecting the same. No matter if it's mild steel, hardened tool steel, or in this case hardened linear shaft, it's always the same deflection on the load. What changes is the load that you need to deform it permanently, but that's not interesting in this case. We don't want to bend this. If you want a stiffer boring bar, you have to go to a material that is in itself stiffer, like carbide. Carbide would be 3 times stiffer. So if you had a nice 18mm piece of solid carbide and we brazed a cutter on the end, that would make for a ridiculous stiff boring bar for the boring head. But then we get into other problems because the whole chain that goes up from the boring head is less stiff than that. But it's an option to go for a carbide boring bar, especially on the lathe. Yes, 28.6. So now we can bring out some more precise tools to check the diameter and bore this to final diameter. In this case I have to use telescoping gauges. My tri-mics top out at 20mm. But I really like the telescoping gauges. I got a nice set of Mitutoyo telescoping and small hole gauges. And I'm really surprised how precise they are, or how repeatable. The precision comes in this case more from the tool you're using to measure it. Okay, 28.775. 28.75. Let's write this down. 28.75. Double check it. Never rely on a single ID measurement with telescoping gauges. Bored the second clamping block too, and now I can show you the actual boring tool that I made. This is really very nice fit in the bore of the of the boring head. And now we'll bring the camera in a little bit closer. As I said, this is a piece of linear shafting, hardened. Ground the flat on it, so it always aligns with the set screw of the boring head. As you can see, the set screw makes a little bit of a mark, but the case of this shafting material is deep enough, so we're still in the hard area and we're not leaving a big old dimple. Took an end mill, 6mm end mill, and I just plunged down and I created this half round indentation 90 degrees to the flat that I ground. Then I took a piece of 6mm carbide, i.e. a end mill shank, silver brazed it in, then I ground the usual boring tool geometry. Few degrees of positive rake like this, maybe 5 degrees. Few degrees of clearance here, maybe 5 degrees too, and 5 degrees to the top, and a lot of back rake in this direction so it clears in a relatively small diameter. As you can see, this clears even in a relatively small bore like this. Could be a little bit less clearance angle, then the cutting edge would last longer. But I bored 2 of these clamping blocks now, and the cutting edge is still very nicely. But that's also due to the fact that I use a very fine grit diamond wheel to grind these tools. This is Fabrication Friday. That's a thing now. What we have here is my TIG welding cart. I have one of those 200 amp DC pulse TIG welders, import. Had it for years, works well enough for my purposes, no complaints. Little problematic on low end currents, but it's okay for my purposes. Has this enormous 17 size Euro style torch, and I also have an air cooled CK size 9 torch for smaller work. This is really cool. I like this one. But this goes up to 200 amps, and the small CK one is 110 amps, I think. Not sure about that, but that's not the topic. TIG welding is, yeah. This old Tony has done 1 million videos on TIG welding, so if you're interested in that, go watch those. His are also more funny than mine. I have I have a cast iron surface plate here. This is my welding table. This is a 300 by 300 millimeter cast iron surface plate that has a lot of dings in it. It's really beat up, and I use this as my welding table. But the problem is it's just sitting on top of my welder, and it's just waiting to drop on my safety flip-flops. So not a good situation right now. Also, this welding cart, this is basically my first or second welding project I did with the TIG welder. I built this long time ago and noticed it has a 10-liter argon bottle back here, which is fine. TIG welder sits here in front, and there is kind of a little bit storage down there. It has these enormous back wheels here, this comically large back wheels, and the idea behind this was that I can drag it up the stairs if I need to do outside welding, which over the last 5 or 6 years I never did TIG welding outside. If I do welding around the house, I do stick weld. Stick welding works outside without a problem, and usually I do not do any precision work around the house, like like on the garden shed or something like that. So, and these large rear wheels, which do not steer, really are bad for maneuverability to move this thing around in the shop. It's like a wheelbarrow. It has 2 steering wheels in front, but yeah, it's not ideal. Also, this cantilever design here is not the best. Storage down there is a mess. Storage for the argon cylinder is okay. This is really not ideal. And I want the surface plate here a little bit secured. So my idea was to build a new welding cart. So this is my new weld cart. At first I wanted to do a full build video of this thing, but when I do fabrication work in here, there is no room left for doing anything with a camera. So I built this thing, and I thought I'd show you my ideas behind this thing. It's welded out of 20 by 20 by 4mm hot rolled steel angle. I had, for some reason, a huge stockpile of that stuff, so I used it. It looks a little bit flimsy, but it's reasonably sturdy. Rolls on casters, nothing special there. 10-liter argon bottle back here. Hold in place with chains, so it does not fall over. I have my welder here. In a glorious moment, I decided to paint the weld card in 6011 Reseda green, same color as my Emco lathe and my Dactyl engraving machine, which was kind of the standard machine color in the 80s in Europe. And for some reason I decided that the welder has to be in the same green, so I took the sheet metal off and sprayed it in the same green, and it looks, to be honest, I'm not sure yet. I have a drawer section down here to keep consumables and stuff like that for the TIG welder. I didn't want to make my own drawers, so I went to IKEA, got a 6-drawer unit out of sheet metal for, I think they cost around 30 euros, and I just cut it in half with an angle grinder and made it part of the weld cart. The sheet metal on this thing is really very thin. It's 0.5mm, so I didn't weld it in. I TIG braced it in a few spots, so it's rigid, reasonably rigid in there. And yeah, it's decent. The drawers are quite nice. They run metal on metal, no drawer slides, no full extension slides, but you can get them fully out if you need to. On this side, weld cap, welding mask, welding helmet. This is an Optrel weld cap. Personally, I'm quite happy with it, but I'm no welder. Hook for the lead of the torch. This is the 17 size torch that came with the welder. And yeah, 1 meter length welding wire back here, full length. I only stock steel, 316 stainless, and aluminum bronze usually. Not aluminum bronze, silicon bronze, sorry. And to top it all off, literally, a 300 by 300mm cast iron surface plate on top here. I saw Robin Renzetti use a cast iron surface plate as a weld surface, and it's a good idea in my mind. So I got me a beater plate for next to nothing, like 10 euros, and I dropped it on top of this weld cart. There is this huge gap back here, 150 by 300mm. I will drop a piece of fire brick in there. And I might even add a vertical piece of fire brick to shield the argon bottles off, with the idea to use this probably for silver brazing and silver soldering too. And have a nice spot back here where I can put hot parts where they can cool off slowly, not with this huge mass of cold cast iron that pulls the heat away in an instant. Oh, yeah, that's a weld cart. I'm quite happy with it. Took me about, including spray painting it, took me about a day to build it. It's not a masterpiece of fabricator's art, but I'm a machinist, not a fabricator. A quick look inside the drawers. I have the consumables for my 2 TIG torches, 17 size and size 9. Gas lenses, normal cups, gas lens for the 17 size torch, spare back caps for the 9 size torch, and tungsten, 1.6 and 2.4 millimeters is what I use. Gray. I exclusively use the gray electrodes. I never had problems with it, and that's what the fabricators at work told me to use. Oh, and of course the TIG finger. Second drawer is welding wires. I have my drops or my remaining wires when I use a full length, and this is what's left. Goes in there. I need some way to sort them, like in half cut pipes or something like that. Again, steel, stainless, 316 and silicon bronze. And I also have some of this stuff on hand. These are 2 different wires in here. One is a Chronitex 252-C, which is a high nickel wire, something like 80% of nickel. And I have a hard-facing wire that goes up to 60 HRC hardness. You use this stuff to do weld build-up on punch and die tooling and stuff like that. It's also nice to rebuild a grinding vise where somebody took a good bite out of it. First you put on a layer of the high nickel wire as a buffer, and then you use the hard face wire to build it up completely, and then you do your usual surface grinding and blending and all the fun stuff. This stuff is terribly expensive. It's seriously expensive. I got this from a mold maker. Just a few sticks of it. So I'm good to go there. And last drawer, CK size 9 torch. This is really cool. It's very nice, very small. One thing, I don't like to use a foot pedal for TIG welding. I'm used to 2T and 4T welding with a button on the welder. That's what I prefer. And I need to get me a button that goes on here for the small 9 size torch. Cap for the gas bottle, spare ground clamp. So yeah, as I said, I'm not a fabricator. I'm a machinist that needs from time to time to do welding on parts. Most of my welding is repairs, and sometimes I weld together parts for machined components, so I do not have to remove as much material. That's especially cool if you do a design out of laser cut parts. Tab and slot, put them together, and then just weld them together. So I hope you enjoyed this mishmash of different topics. I would prefer to go back to the project and workpiece related videos where I show a lot more machining and setup and things like that. But at the moment that's not really happening. A lot of the customer work I'm doing currently I cannot show. No photos, no videos. So it is what it is at the moment. Thanks for sticking with me, and thank you all for watching. See you next time.